about what we're calling inverse variation. Yesterday was direct variation. As one thing goes up, the other thing goes up. So what's inverse? What's inverse? Very good. You exercise more. Usually, your weight goes down. Or the amount of calories you consume decreases as you exercise more. They get burned away. Or, let's see. You drink more coffee, you get less sleep. Not traditionally, or not assuming that, but traditionally you would say you drink more coffee, you sleep less. Caffeine keeps you awake. Those are inversely related. Caffeine intake versus hours of sleep. So we're going to talk about indirect variation here. And then what we're going to talk about is called joint variation. And that's where we have direct and indirect variation at the same time. Many of your science courses going forward involve direct and indirect variation. So although this is only 2 topics in math, you will use this concept literally in chemistry and in physics so much in the next 2 years. It's really important that you learn this and learn it well as a freshman. Okay, you're not going to see as much of this in your biology course right now. But in your chemistry and your physics course, you do a ton of stuff with direct and indirect variation. Maybe in bio too, actually. I don't know. So let's take a look at this example to start. Instead of y equals k times x, we now have y equals k divided by x. So the equation for inverse, another word for inverse is indirect. Okay? Indirect or inverse variation is y equals k divided by x. Now, what does that look like graphically? This is what it looks like right here. That's what you're seeing. And make sense of it. Plug a number in for x. Assume you have a certain k value. What's going to happen is this is going to decrease as x gets bigger. Why is that physically? How come as x gets bigger, this graph is a decreasing function? Why isn't it getting larger? Because it's indirect, good. Mathematically speaking, what are you physically doing? As x gets larger, you're increasing what part of the fraction? In this case. Not the y part. I mean, of this fraction here, right? As x gets larger, you're increasing the what of the fraction? The denominator. When you increase the denominator, your answer gets smaller. We've talked about this a couple times now. Divide by a bigger and bigger and bigger and bigger number. Take a piece of pizza, or take a pizza. There are, in this class, 10 of you. Let's say there are 8. And you have a pizza. Everybody gets how much? 8 people? Everybody gets a slice, right? Now there's 16 people in the room. Everybody gets a half a slice. Now there's 24 people in the room. Everybody gets a third of the slice. So as there are more people dividing up that pizza, everyone gets less and less until the room is full. You each get like a little, square inch of pizza, like a tiny little bit. Because you're dividing by a larger and larger and larger number. It's like divvying up the winnings of a lottery ticket. Have you ever heard those stories where an office goes in and buys like 100 lotto tickets, and everybody that buys into it gets a little cut of the win? This has happened before. They've been like lotto. So when you win lottery, obviously you get a certain amount of money. But when offices go in, we've done it in Loyola actually. We put like when the Mega Millions was at like 600 million at one point last year. We used to earn like $5, like 10 of us. And put $50 worth of lotto tickets, hoping that, who knows, we win, maybe get 50 tickets, a high chance, hoping that one of us would win. But we agreed to split it 10 ways. Because you're splitting it more ways, each person gets less. That's what's happening here. Okay? The denominator is x. If x continues to increase, the whole fraction, which is k over x, has to get less and less. And k over x is represented as y, so y becomes less and less and less as x grows. Another way of writing indirect variation is seen right here. The product of x and y. And that just means solve this for k. Look at this equation here. To solve this for k, you would just multiply x up, and you get this equation right here. Again, k is still the constant of variation. All right, so let's get into some problems with this. So let's take a look first at number 1. If c is inversely proportional to d, and we're given a certain condition, well, then find certain things. So let's go ahead and write right away, because it's inversely related, right away, that c equals K over D. I like to write these equations, by the way, with the fractional form. I don't like to write it with the product. It could be useful with the product, and I'll show you an example of that in a little bit. But I like to write it this way to start. So C is inversely proportional to D. That's what I've got so far. I'm told that when C is 2, D is 3.6. Which allows me to say that K must be 7.2. I boxed that in temporarily. It's not the answer. I know it's not the answer. But that's my starting point for all of these problems, right? We did this yesterday. You got to solve for the constant of variation first. So we go ahead and do that. We have our constant of variation. Now, for parts A and B, we have to go ahead and apply what we know. So once we have the constant of variation, let's go ahead and plug it back in for K. And this becomes C equals 7.2 over D. So that's my specific equation, again, in blue. My general equation is what I started with in red. I get the constant of variation. I go ahead and plug it in to my general equation to write out the specific equation. Now, I go to part A. Part A says to find the value of C. So let's write down, this is part A now. I want to find out the value of C when D is 4.5. That's what part A tells me. Literally just plug in for D. Just plug in 4.5 for the D value. This becomes C equals 7.2 over that 4.5 right there. Bless you. So that gives me a C value of 72 over 45, right? I can divide them both by 3. What does that give me? 18 over 15. 6/5. So 1.2, is that right? No, that doesn't seem right. No, 24 over 15, that's why. 24 over 15 is 8/5. So this is going to be 1.6. Check my math on that, but it should be around 1.6. By the way, mental math, we got to get better at this, and I talked to you all about this, so I'll point out what did I just do to get that quick reduction?
You transposed the whole number.
See what I do right away? Whenever I have two things with tenths, just move both decimals over. It's multiplying top and bottom by 10 each. You're not changing the value. 72 over 45. 72 divided by 3 is 24. 45 divided by 3 is 15. 24 over 15 reduces to 8 over 5. That's where that reduction all came about. Anyway, you get 1.6. But try to be able to do this kind of mental math. Move things over to 72 over 45, and then reduce each. So I get 1.6 for the C value when D is 4.5. And then part B is no different here. Part B is no different. I have the same starting equation. Okay, there's my specific equation I use. But now, I need to find D when C is equal to 6.4. So let's circle what we're looking for. Okay, in yellow up there, that's what we're doing. Find D when C is 6.4. Plug it in. Solve for D. This becomes 6.4 equals 7.2 over D. How do I get D by itself here? How do I get D by itself? Some of you have struggled with this part in the past, so I want to ask to make sure we understand. How do you solve for something in the denominator? Yeah, multiply the D up. Don't divide by 7.2. And I see that so often, whether it's in junior physics or in this course. People divide by 7.2, and that leaves you with 1 over D. That's not what you want. So multiply by D and divide by 6.4. So remember we talked about switching diagonally here? So this is one of those cases where you're just going to switch these two. So this statement becomes D equals 7.2 over 6.4. 72 over 64 becomes what? 36 over 32. What do you got? 9 over 8. Sounds good. 36 over 32. 9 over 8. Yeah. Anybody got that as a decimal without their calculator? 9/8. 1 1/8. Right. 9/8 is 1 1/8. Anybody know their eighths?
120.
Very good. Well done. Okay, 0.125 is eighths. 0.25 O's, 2 eighths, 375 is 3/8. Eighths are good to know as far as decimals are concerned, because why? Because if you look at measurements on an English system, they go by fractions, right? Half an inch, quarter of an inch, eighth of an inch, 5/8 of an inch, 3/8 of an inch, 7/16 of an inch. So it's good to know eighths and decimals. Right? So that gives me my answer for part B, and here is my answer for part A. Again, both are correct left as fractions, 8/5 and 9/8 as well. Questions on this one? Let's go right into the next one then. For cones of equal volume, the height is inversely proportional to the square of the radius of the base. Stop there and write yourself a formula, please. For a sentence, write yourself a formula. For cones of equal volume, I'm going to use the variables they give me. The height is inversely proportional to, I'm doing this one step at a time as I would mentally think about it. So again, the height tells me this right here, is right here, inversely proportional to k over the square of the radius of the base. The radius squared. Again, the height is inversely proportional to the square of the radius of the base. I could call that RB for radius of the base if I wanted to be a little more specific and give it a little subscript like RB, but it's no difference, so I'm not going to do that to confuse things. Okay, the radius of the base squared is what it's inversely proportional to. So that's the first sentence alone. So we really, at this point in these problems, can say this. Here we're done with this part, right? We could do that at this point. We could say we've utilized that statement. It's no longer helpful. So now I need to press on and go to the second statement. If the radius of the cone is 10 centimeters and the height is 15, well, that gives me a condition. Let's underline that in red. That's my condition that's given. So let's go ahead and apply that condition. If the radius is 10, when the height is 15, and then it says the next part, we're going to go ahead and find the radius, but I can't. I can't do the second part. The second part tells me the height is 60. That goes here. And then I want me to find the radius, which is here. If I have 60 here and I want to find the radius, I need k. So let's go ahead and solve for k once again. 10 squared is 100. 100 times 15, 1500. Again, take this value, plug it back in to the original equation to give me the specific equation over here on the left. And then go ahead and solve. Find the radius. Let's use another color for this so we can see the difference. Use green. Find the radius of the second cone of equal volume with a height of 160 centimeters. And the key here, it says in the beginning, for cones of equal volume. And this says the second cone of equal volume, which means you can use this proportionality here. What do you got? R equals 5. I'm going to flip-flop these, right? Reduce this by just crossing that off. 150 over 6 is 25, so therefore R is indeed 5. Okay, the units are centimeters. I don't need a plus or minus here. I don't need the plus or minus because it's a radius line. It's a radius line. Notice the mental math again. You should be able to do this. You do not need a calculator for any part of this problem. Literally. I'm not taking out a calculator, and you can see how easy the math is. Reduce appropriately. Drop the 0 off here and here. You can always do that if the 0 is at the end of the number. 150 over 6, you should know your quarters. If you didn't know that, what's $1.50? It's 6 quarters, isn't it? Physically. $2 is 8 quarters. Right? Think about quarters physically, quarters in your pocket, quarters when you're dividing by 4s. Questions on example 2? It's more of a word problem example. Let's get to the tough stuff now then, all right? So let's talk about this next thing, which is going to be the idea of direct and indirect variation at the same time. When this happens, we call it joint variation. The joining of inverse and direct variation is the idea there. So my concept here is to recognize that I'm going to have something that says y equals kx, but I'm also going to have something that says y equals k over x. So I'm going to have something in both the numerator and denominator in this problem that's not k. So if I think about it, combine these two in your mind, please. This is direct variation. This is indirect variation. If I merge these together, I'm going to see that x appears in the numerator and the denominator. They're not going to cancel. I want you to do that. Imagine they're different variables. But the concept of joint variation is having something like this. That's joint variation. Because look, y, I'm going to read this, okay? I want you to write this down if it helps. I'll point. Y is directly related to x, but indirectly related to w. Again, the statement here at the bottom really reads y is directly related to x while being indirectly related to w. So we have the combination of both direct and indirect variation. I'm going to do a little more in a second, but any questions so far? Oh, there's a typo here. That should say Newton, not Newtowns. Newton's law. Correct that. How many years have I used these notes? Never corrected that. Dang. All right, so let's look at this example. For example, Newton's law of gravitation states that the force of attraction between two spherical bodies is directly proportional to their masses and inversely proportional to the square of the distance between their centers. It's directly proportional to the masses. So what could I write from that? And there's two masses, so be a little bit careful here. It's a little tricky. I'll put F for force to start. The force is directly proportional to the masses, M1 and M2. And it's indirectly or inversely proportional to the square of the distance. What do you got for start?
Would it be M1 plus M2 for the numerator?
Not plus, but multiply. Yeah. Remember, K is always the numerator. Please look up here. K, numerator. K, numerator. It's always the numerator. Your constant variation always goes to the numerator. Because this problem says that it's directly proportional to two things, both of those things become multipliers. It's multiplication you're going to use. But then it says that it is inversely proportional, so I put a fraction line, to the square of the distance being r. It says inversely proportional to the square of r. So I simply put r squared in the denominator. Again, the force of gravity is directly proportional to the masses M1 and M2, and indirectly proportional to the distance between the masses squared. Right? The square of the distance between the centers, the masses. So that's just a quick example to see that. Let's go on to the next one so you can see a little bit more. I'm giving you, these next two are all physics examples, and I purposely did this so you can see that it doesn't matter what you're given. It just matters what you write. It could be y and x, it could be other things, but it does not matter what you're actually given here. Now, you can use any variables you want, but to be consistent for today, let's use for electric field, let's use capital E. For charge, let's use Q. And for distance, let's use R. I'm going to give you variables so that when we do this, it all looks similar, instead of using y and x and everything else. So let's go through this problem, and you pick your own variables, obviously. the test, right? But so we're consistent amongst this class, this session right now. Let's use these variables. The electric field, I'm calling it E, produced by a charged particle varies directly with the charge on the particle, and it varies inversely as the square of the distance r from the charge. So that is one long sentence that can be summarized with one simple mathematical statement. Valentina, what do you got for this? I agree with that. And let's take a look again. Let's point some stuff out. We'll take it one step at a time. I will read as I'm going to point here so you can see again what's happening. So ready? The electric field produced, E, by a charged particle varies directly with the charge. That's right here, direct variation with the charge, Q, on the particle. And it varies inversely with as the square of the distance r from the charge. So again, inverse variation to the square this time, direct variation to the charge Q. Any problem could be different. It could vary inversely to the cube of the distance, and then it's r cubed in the bottom. It could vary directly with the square of the charge, then it's q squared in the numerator. But it depends on what is written in the problem. What makes this easier is practice. Again, is practice. If you practice enough of this for homework and with your problem sets and do it extensively, it will make it easier and easier and easier. This is almost like a freebie on the next test, okay? Because there's no other way to do these problems besides k in the numerator, whatever's directly related in the numerator, whatever's inversely related in the denominator. That's what happens. You picked up on it by now. Direct variation, that variable goes in the numerator. Indirect variation, denominator. That's it. Okay, but joint variation is a very easy example of these two combined. Now, we're told that on a planet galaxies away, the electric field felt at a distance of 13 meters, so that goes here. Oops. At a distance of 13 meters from a charge. So again, let's read it carefully. The electric field felt at a distance of 13 meters from a charge is 25 newtons per coulomb. Who cares about the units? You guys have no idea. You've never seen these units before, right? Newton you've heard of. Coulomb you've never heard of right now. But it doesn't matter what the units are for this problem. Okay, don't worry about them. Just figure out what the problem is asking you. So again, the electric field felt at this distance from the charge is this. Well, that's the electric field felt. So that's going to go in right here. The electric field felt at a distance of 13. Distance goes in for R. The electric field felt goes in for E. That's 25. When the charge on the particle producing the field is 8 coulombs. Again, who cares about the unit? It says, when the charge is 8 coulombs. That's going in for charge, which was represented by Q. So that's an 8. And again, what are we solving for? Yeah, K, the constant of variation. K is going to be messy. I got to multiply by 13 squared and divide by 8. K is going to come out to be 528. I'm not going to do that. I didn't do it in my head, by the way. I'm just doing it quickly. Okay, 528 it turns out to be when I solve for it. Now, right, because K is times 8 there. Be careful. I go ahead and write out my specific equation now. There's my specific equation. Again, the same exact process. Plug in a condition, get the K value, write out your specific equation. Now answer what is being asked. Determine the charge that would produce a field, electric field, that goes in here, of 18 newtons per coulomb. Determine the charge. That means we're finding out what Q is. Determine Q. If the electric field is 18 at a distance of 11 meters. Plug 18 in for E, plug 11 in for R, and solve for Q. That's it. Around 4.1 I wrote down, so I must have rounded. 4.125 to be exact, sounds right. Please, tonight, make sure you finish the last one. You need to go through this, even if it means looking at the notes with it, or at least watching the last part of the video. Okay, and then you have homework for this. This homework is not due until Thursday. You have a quiz on A1 and A2 on Thursday. Okay, again, if you have questions and you're struggling on this, want to come after school today, these will probably be delayed because of the weather about an hour. If you want to come after school today, it's probably not a bad idea. Sorry, quiz on Friday.
And why does 55 the charge?
Let's go back and look. It's worded oddly, I noticed that. So, it says